The learning objective for this particular topic, we want to look at parametric equations, and after this lecture, hopefully you could be able to identify parametric equations of basic curves, such as a line or a circle or an ellipse. Right? So recognize the parametric equations of basic curves, such as a line or a circle. You could learn how to convert the parametric equations of a curve into the form that we know, which is y equal to f of x. And this form is in the xy plane or the Cartesian plane or the rectangular plane or the rectangular coordinate that we learn in single variable calculus. Right? And the process of converting the parametric equations to the form that we know y equal to f of x is called eliminating the parameter. And we learn how to plot a curve described by a parametric equations. So about parametric equations, I bet you have seen parametric equations before, but we didn't introduce to you that way. We didn't introduce to you, okay, this is the parametric equation. We didn't do that. But you certainly have seen parametric equations in form of the unit circle, right? So before we go into the definitions of parametric equations, I just want to give you a quick motivations example, right? A motivations example, right? So the equation of the circle, or the equations of the unit circle, is given as, right, you have x squared plus y squared equal to 1. And this is what you learn in pre-calculus, right? In pre-calculus, you learn about trigonometry, right? And they introduce to you the unit circle and also the terminal point on the unit circle, right? So in order to find the terminal point on the unit circle, that means you have to evaluate the value of x and the value of y. And the value of x can be evaluated by letting x equal to cosine of theta or cosine of t, and y is equal to sine of theta or sine of t, right? So the terminal point on the unit circle can be found by calculating the value of x and y for some particular angle t. In trigonometry, usually we use theta for angle, but for parametric equations, usually the angle is used is t. So that is, we have x equal to cosine of t, and y is equal to sine of t. So this is the unit circle, and for each particular or special angle, you have a terminal point. For example, for the 30 degree or pi over 6, the point is x equal to root 3 over 2 and 1/2. For example, pi over 2 or 90 degree, the terminal points you have is 0, 1, right? So x equal to 0, y equal to 1, right? So in order to evaluate the location or the value of x and the value of y, right, you have to use the third parameter or the third variable to do so, right? In this case, the third variable or the third parameter is the angle on the circle. So that's the idea of the parametric equations. So the takeaway point here for this quick, simple example is that parametric equations are mathematical statement that describe a relationship between two items via a third common item. So in the example of the unit circle, right? In order to calculate x and y, or we relate x and y through the parameter t, right? So in this case, t is not only called the angle for the unit circle, but also the parameter for the parametric equations. So let me give you the formal definitions. This is for parametric equations. A curve y equal to f of x. So remember, you see the word that I use, just a curve, not a functions, right? We haven't talked about function just yet, right? Just equations and curves. Right? So a curve y equal to f of x can be parameterized as x equal to f of t and y equal to g of t, right? X and y can be related to one another through the third parameter, which is t, right? And in this case, x equal to f of t and y is equal to g of t, or we can write c of t is equal to f of t comma g of t. So these notations indicate that where c of t is called the parametric curve or plane curve. Right, plane curve because it's still on the xy plane, right? Later on, when we put in the extra dimensions, which is the vertical dimensions, then we have something called surfaces. T in this case is the parameter. So with this value of t, we can have the restrictions on t, or don't. I mean, it's not necessary to have the restriction, but when you write the parametric curve or parametric equations, it allows us to have some restrictions or domain for that matter. So t parameter, where t can be restricted between a and b. A can be negative infinity and b can be positive infinity, right? Doesn't matter. The point f of a comma g of a is called the initial point of the curve. And f of b comma g of b is called the terminal point of the curve. Okay, so give you a quick example here. An ellipse of the form x over a square plus y over b square equal to 1 can be parameterized as x equal to a times cosine of t and y is equal to b times sine of t. You can put some restrictions on the ellipse, right, where t is between negative pi and pi. Right? If you don't put restrictions, the point is just moving around the ellipse, right, over forever. So let me show you a tool that helps you with drawing some parametric curves. Of course, to draw a parametric curve, you can just basically find the value of t, substitute into the parametric equations, and get the point x and x comma y, right? And you can plot the parametric equation or parametric curve that way. Right. You can do it by hand, but there's an online tool I think is very useful for us to know, which is the desmos.com website, which allow you to draw anything you like. Okay, so here is the parametric curve circle, right? So x is equal to cosine of t, sine y is equal to sine of t, and the circle is bounded, or the parameter is bounded between 0 and 2 pi. So you can see this is the unit circle. You can draw an ellipse if you like, right? So here I bounded the ellipse between 0, the parameter between 0 and 2 pi, but you can certainly change this to between negative pi and pi kind of the same thing. There's a lot of cool pictures that you can draw, right? So a lot of cool picture. And one of the pictures that I found is the picture of the star, uh, using parametric equations. As you can see, it's just a bunch of sine and cosine functions put together. Right. So this is parametric equation is a very powerful technique for you to draw some difficult curves, right? Instead of writing them in terms of y equal to f of x, you use the third parameter and you write them with respect to the third parameter. You can have some very beautiful plot like this.